Hi everyone, I'm Massimiliano and I will be guiding you through the steps that are necessary for installing and starting to run things for this Telluride tactile workshop. In this case we are talking about the contour following task with the iCub robot. And in order to do this, we have provided a Docker image which contains all of the necessary packages, middleware and simulation tools already nicely packed and installed in a hopefully easy way to use. So now let's get started here at the GitHub page of the Telluride TAC 21 contour following repository, and you can see that here there are instructions on how to get started, and I will guide you through this readme and all of the instructions, and we're going to look at all the necessary steps together. So if for those of you who are not familiar with Docker, Docker is a method that provides a simple way to create a development environment which prevents you that will be using the system to not have to install dependencies and libraries and set up the environment variables and all these kind of things that can be quite painful to do if you're not an expert user. This is done using an image. The image is exactly this archive, this storage which contains the whole file system of functioning Linux system that with all the files, libraries and code repositories that are installed inside that archive. From that image you can spawn a container which is an active instance of that image, and this is where you can actually do your things, run your application, do your development. And we provide already the image pre-built, so you just need to download that and run it, and I'm going to explain you how. But of course, as a first step, we need to go through the installation of Docker on your computer. So in this demonstration, I will be using a Ubuntu 20.04 based distribution, and so I recommend you use the same, but even others Linux distribution will be compatible. I don't have support for Windows, but expert and brave users can definitely try to run things on Windows as well, because Docker is also available there. So if we go at this link, we can see there are instructions for installing Docker, and if we go on Ubuntu, then we can start following these instructions. And this is actually pretty easy. It's just a matter of copying over some commands. So this is to get rid of previously installed container Docker, but we don't have it, so we just go here, we copy this over, and this were already installed. Then you can do this to add the repository. Then again we can do this to add the repository to the list of repository where apt is going to look for. Now we do an update. Oops, I can just type it, and then I can do this. And this is going to install the Docker inside our computer. So after doing this, I actually recommend go through this post-install steps. So we just need these two commands, if not only this actually. So we can do this, and this allows for using Docker without sudo, and this command here will now re-evaluate our permission. So if now we test our installation, this should run smoothly. So you see that everything works fine. Here it says that it doesn't find the image locally, so it's just pulling it from cloud, and this is just a demonstration that, so I just test sanity check to see that everything went correctly. So this is also explained here. Here also in the instructions we see a list of useful commands. Maybe we can go through the one that we are actually going to use, which are the following. So you see here there's a command which contains a lot of options and parameters, and those options are actually necessary for us because we need to use graphical interfaces, and this is going to enable the graphical interfaces that can be run from within our container. But also what we need is the NVIDIA support for GPU intensive graphical applications, which we actually will have to use because the gazebo simulator is pretty slow without a GPU. And so in order to get this, we actually need to install the NVIDIA Container Runtime, which is explained, which has installation instructions at this link. So if we go here and we go to here, so we need first to install the repository for our distribution. So let's look for so we need to go to Debian based distribution in this case, and we just copy this command. Okay, so we have to define the distribution as Ubuntu 2004, and now we can run this command here, and then we can run an update, and once we do the update, we can finally install the NVIDIA Container Runtime. Okay, that was already installed for us. And also we need to enable it by doing this. We just need to follow this section here, so just copy all of the command over and then restart docker. There we go. So now we have the NVIDIA container runtime. This will allow for using the GPU inside the container. Okay, so now we have here this command which will run our image, this event-driven robotics / Telluride image, and since this is not present in our system, we will have to download it, and this will happen for you as well, but this is only downloaded the first time that you run this command, and once this is downloaded, it will be stored inside your computer, and then you can still call this command to start new containers from this image. Okay, so now that the image has been downloaded and run, you can see here that you have a bash which is running inside a container. You can tell from the fact that you have a root user and this weird host name. That can be fixed easily, but that doesn't matter. Let's go back here. We can see that for instance, we can run even graphical interfaces. In case you get permission denied on running graphical interfaces, that's because you have to authorize the X server on your host machine using this command, or even better, you can add these 4 lines to your etc profile, and this is something that I have done already. So here, if I Control D, I exit the container, and I can show you that inside my profile I have this. So this is run every time I need I run a bash, so that means that the X server is always authorized to run application graphical interfaces applications that come from Docker. So now we are back in our host, and here you can see that we indeed have, so if you run Docker images, you can see the list of images, and here we have the image we just downloaded. And also, if you run docker ps-a, you can see all the containers. So here we have the Telluride container, which is based on the event-driven robotics / Telluride image, and this is the container that where we're going to run our development. So because this command can be quite tedious to remember, and I totally understand if you don't want to remember it, I have provided an easy way to run the Docker with a consistent set of options, which enable the X server forwarding, so the graphical interfaces, which sets the host name, sets the name of your container, but also it provides a mapping between a set of folders that you can have in your host machine. And I have defined, in my case, 3 directories, which are code, data, and apps. And so if you store your code inside a directory, your data inside a directory, in your applications, in my case those will be IDEs, inside another, you can access those locations inside the container, and every modification that to those directories will be reflected on both sides. In brevity, those directories are shared among your host machine and the container, and this is quite convenient to have, especially if you are doing development, because you don't want to modify the code or write on files inside the container, because those are the containers are easily disposable and it's very easy to lose your work. So in order to avoid this, I have provided here this inside the Docker. There's a bashrc Docker file here that you can let's see here, you can get it. Let's call this bashrc Docker. Okay, and here I can basically copy the content of this file, and now I can source this file from our bashrc. So because we also have here auto-completion capabilities, we want to make sure that we add the source of this file after the bash completion, and we need to make sure that this is actually run, so it's not commented in your bashrc for some reason. Okay, so inside our bashrc we are going to specify path to code as I have it in home code, and data is in home data, and apps is in home apps app, sorry. And then we need to source again home /.bashrc Docker. Okay, so now we can save, and now we either start a new terminal, and now you can see that we get these functions that are defined inside here. So if you take a look at this, you can see that there are basically three functions. One is run Docker, one is run Docker OpenGL, and the other one is start Docker. So these commands basically do pretty much the same thing as those that are explained in the instructions, just they add also the mapping of those volume. Okay, so now that we have those commands available, we can do run Docker OpenGL. I add also OpenGL because we do need the NVIDIA support for this case, and we can run the image that we have already downloaded in the container that we are going to call Telluride. Of course, if there is a container already running on the same name, we need to get rid of it, and there we go. Okay, so now we have everything ready to be used. So inside here, so first of all, we can find here the three directories that I was mentioning earlier. So if we go inside code, here I have all of my repository and things that are actually stored inside my computer. So here, and same thing goes for the data folder, and same thing goes for the apps folder. This apps folder is particularly useful if you have an IDE that can be run, let's say, with a standalone executable in like CLion or PyCharm. Those are very useful to have. And now let's see this thing running. So if we do so first let's open another terminal, and here we want to add another bash to our to the same container. So we run this command that is actually attaching a new bash to the already running container. Here we want to launch a YARP server. So YARP, as explained also in the instructions, is the middleware that we are going to use for the purpose of this workshop. And for YARP to work, we need a YARP server to be running constantly in the background, because this is the module that is in charge of forwarding the connections to all the modules that are running. And also YARP allows us to have this graphical interface where we can run applications from. Application is nothing more than a list of modules. In this case we have already provided the iCub contour following application, and you can see here that there is a list of modules with some parameters that we need to run in order to properly simulate the robot. So if we click here, now everything will start, and so you will see that we have the simulation here. Okay, we don't need the legs because actually they are not even activated. But so here, as you can see, we have the simulator with our robot. We have this is a logger where you can see the output of each of the modules. So we are not going to look at this now. Oops. Actually, let me move it somewhere else. And what's this? And now you can see that we have the robot in its simulated environment, and we have here a small GUI that allows to move the joints, the individual joints of the robot. So you see now that the neck is moving as I move this slider, and this can be done for every joint of the robot. Okay, so also we have here models. Sorry, here we can insert a set of models. Those are the models that we are going to use for our task. So for instance, we can drop here the 2D circle. Let's put it on the table. Yes. So you see that we have this shape here, that is the shape that we will have. We will need the robot to follow with its finger according to the task of this group. And also, I mean, we have a bunch of these, and all of these are also explained here. So here you have the list of the objects that we are going to use for the for this task. Now if we go back here, sorry, not here, we can see how to start developing for this task. And here again I can attach a new bash to the Telluride container. I'm going to go inside the bin directory of CLion. From here I can launch CLion. Yes, okay. Let's move to a new. Okay, and now we can open the code. So inside the code directory you should have cloned the repository, the control following repository, where all of the instructions are and all the code is. And here we can take a look at the contour following.cpp file. So this is the file that we're going to modify, we're going to edit for running, for performing the task. And here there's already some code available for you that that basically does some very basic things, even though it's pretty long to look at. But if we go to the main, in the main we have the connection to the YARP server, so the one that we run already on the other terminal, and then we have this contour following model that is the module that is going to where all of the action is going to take place. And so as a first thing, if we look at the configure method, this is where all of the initial, let's say, settings need to be done. So first we read the parameters, and so if we look at the parse, where is it? The parse params, sorry, yeah, there it is. So if we look at the parse params method, here is where we are reading at all the different parameters that we can add to this to the execution. So the name of the module, the robot name, in this case is iCub sim because we are working on the simulated robot, which arm we are going to be using, in this case right arm, and this is the update period of the module. Then if we go again to the configure, yes, we have this open drivers method. This is necessary to run the Cartesian controller. So here is where we are enabling the Cartesian controller interface, and this is useful if we want to move the end effector of the robot in 3D coordinates, in XYZ coordinates, rather than in the joint space. But also we have position controller for each part. So we have position control, so this position control for the right arm, left, head and torso. We are not talking about the legs in this, it's out of the scope of this task. And so these pieces of code here is opening one position control interface for each part, and also it's enabling the interfaces to read the encoder values and to define the control mode of the Cartesian controller. We're going to see after how this works. Now the next thing is to move the end effectors to the fingertip. So if we the end effector of the iCub is basically placed in the middle of the palm, but we want it to be on the fingertip, because our goal is to move the finger to the edge and then do the following, and this is going to happen using the Cartesian controller, but the Cartesian controller needs to control the fingertip rather than the palm. And so we have this method here that is basically reading the encoder values and attaching this tip frame. So it's basically telling the Cartesian controller not to use this position to control, but to add to this position the kinematic chain that links this position to this position using the encoder values that are in between. And so once this is done, we can use the Cartesian controller to move the fingertip, so to define directly the fingertip position. Here we have home function. Here you can see there's basically our coded position for going back home, and then we have here we can see how that we set for all of the joints, we set the control mode to position control. That's because we're not going to use velocity control or torque control or any other fancy stuff for this task. I don't see the point in doing that at the moment, but you know, that's also up to you. And here we are defining, so here we are setting some parameters for the Cartesian controller and we are also defining which degrees of freedom are enabled. So we are basically turning off the degrees of freedom of the torso, so we are only going to be moving the shoulders, the elbow and the wrist of the arm. That's just because you can get into some weird configuration if you also include the torso, but again, this can change in the future. And here we define a starting position for the robot. So this is basically a position in the 3D space, and this is a rotation that is that moves the hand from this position to this position, and then we also define an impact angle, so let's say this, which is this rotation, and this rotation here, the amount of this rotation is defined by this angle in radians here. And once we define the orientation, the orientation vector defined in axis angle representation, we can send this to the Cartesian controller to actually perform the motion. So at this point the robot will be in its starting position. Also, we need to open the port where we want to read the data coming from the skin, and so this piece of code here is opening the port, and this is done twice. So it's opening the port, and in case something happens, we are just going to stop the execution. Here is where we perform the connection, and so after all of this configuration is done, the module will start spinning, and the update loop is defined inside this method here, update module. At the moment we are only reading the input from the skin event port and printing it as screen, and this is where you are going to put your code to actually use this input to perform the motion with the iCub robot. And we also have, so this is in a synchronous update. As I told you before, there is this period, where is it? Yeah, this period parameter, which defines how often that the update module is called. But also we have another method, this run. At the moment it's empty, but this runs in a separate thread, and it runs just as fast as it can. Here, if you need to do any asynchronous operation, this is the place where we want to put our code. Here there are some an interesting thing for you at the moment, and so we can see what happens if we start this. Let's go to the simulator. So now the robot is going back home, is closing the hand, and is moving to a starting position. And now from this point on, this is where the rest of the application and the rest of the task should start. So we need to move this to this shape and start reading the input from the events. So that said, I will conclude this tutorial, and good luck and enjoy.